Today's program is full short. We will be shorting a 2D array. This program is the simplest program you will ever see for full short of 2D array. This uses basically a bubble short. This is not actually bubble short, but you can call it a bubble short. I will first show you how to short a 1D array. Just explain you how do we short a 1D array. After that, use the same principle of 1D array sorting and apply it to 2D array sorting using a slight twist. This is the main code for sorting 2D array. So I'm CJ, welcome to Education Valley. Today we have another amazing video on the Java program, so let's do it. So first I'm sorting this 1D array. So what do we do for 1D array is I use two loops. The outer loop will contain one number and inner loop will go through rest of the number and compare and swap. Then the outer loop will move to the next number. Outer loop will move to the next number and the inner loop will go to the rest of the program again and swap whenever it is needed. If we are sorting in ascending order, if the number is smaller, we will swap. If the number is big, if we are in descending order, if it's bigger, then we will swap. So let me demonstrate it first using the array. Okay, so here is this array. So the outer loop will start at 0th position, of course, and inner loop will start at 0 plus 1 position. Here in 2D array, we are using both starting position as 0. In 1D array, you can either start at 0 or you can start 0 plus 1 or I plus 1. So first we will start at 0 position. This is the outer loop position. This is the inner loop position. The inner loop checks if swap is needed. Yes, swap is needed at this point in time, so it will swap. After that, the inner loop will move to the next position. The inner loop will move to the next position and it will check if swap is required or not. If it's not required, then it moves to the next position. If it check if sort is required or not. If not required, it will move to the next position. Here it is required, so it will swap again. So essentially the smallest number has reached the first position that was being held by the outer loop, and the inner loop comes back to like the first loop. After the outer loop will terminate and the smallest number will reach that first position. After that, the outer loop will come to the second number and the inner loop will come to the third number. Once the inner loop comes to the third number, like it can start at 0th same position or the next position. Then the inner loop will move to the next number and it will check if swap is needed or not. If it's not needed, it will leave it. Otherwise, it will then move to the next number. It will check if swap, check, and then swap. After that, the inner loop will move to the next number and check if swap is needed or not. Here it is needed again and it will swap again. So after that, the second smallest number will reach the outer loop position and the outer loop will terminate and the inner loop will terminate and the outer loop will move to the next position. Then the inner loop will start at that position and then move to the next position, and then this keeps on happening and it swaps whenever swap is needed, according to whether it is descending or ascending. In this case, we are using ascending, so whenever a smaller number is found, it will swap. So this goes on and eventually at the third position we will have the third smallest number, and then the inner loop terminates, the outer loop will go, and then this performs the final swap and our whole array will be in ascending order in this case. So that is the same principle we applied to the 2D array. But in 2D array, we have to hold 4 positions. First, to hold the position of one number, we need 2 we need two for loops, and to hold the second position we need two more for loops. So we apply 4 for loops and then do the swapping, the same swapping. Everything else remains the same except this ternary operator. Everything else remains the same. So let me go through in this example to demonstrate, and then I will explain why this ternary operator and how this whole code functions. So rest all the program is very simple. Let me walk you through all that program. After that we will see the main thing. So this we are printing. This is very simple. Let's start. So we open a program, we create a scanner we use an object to take input. After that this system.out, we print the size. We ask the user for the size of the matrix. We take in the size of the matrix. After that we do a reverse checking to see if the user has not imported wrong number. Wrong number in this case is like, this is for a school level program, so teacher cannot go on inputting numbers, so we have to enter a reasonable number that can be entered. Otherwise, then if the imported number is right, then we go on declare arrays, because we don't want to make the program long excessively. After that we ask user to enter numbers in the array, and then it enters the number in the array. We declare an empty array and then take numbers in that array using 2 for loops simply, and using that same object to take input. After that we display the inputted array. Why we display the inputted arrays? Because when we input arrays, it's generally in the linear format, but when it's in the inputted array, like properly displayed with spaces and lines, different rows and columns, it will look better, and we can compare and see that actually the numbers has been sorted. So we come at last to the actual sorting algorithm. So actual sorting algorithm, this is the simplest algorithm you will ever see. This is not the most efficient, but it is the simplest, because at school level you require simplicity over most efficiency. After that we just display the array using the same method and spaces and lines to create rows and columns as we did before. So let me demonstrate it with an example. So when first the outer 2 loops will hold this position, and the inner loop will start from this position only. After that it will move to the next position. After that it moves to the next position, like this. This is the row column row column. First this column this moves, column this terminates. After that it moves back to the rows. When row is increased, it changes from, like, it's from the start with j and then it moves to the 0th position. That is why the ternary operator is needed. That it keeps at end it moves to the 0th position. After that it moves here, and then after that it moves again to the 0th position. This is how it functions. So let me demonstrate this with a proper example of sorting that array. For loop holds this and j holds this 0. K holds same as k holds for this. Let me demonstrate for here right now. K holds this at next position, and L holds this upper column 1. So this is the, let me show for example this. Let me start with here. So ij will start at, let me make it smaller, 0, 7. So no sorting will be needed above that. So the outer two loops will hold this position and the inner two loops will hold this position only. But then the inner loops will move to the next position to checking to perform the check. If check is done, yes, it will move, it will swap. It was 16, I think it was, yes, it was 16. So it will swap after that. It was here, so it will swap after that. So how ternary operator operates is, if the condition is right, the first one is used. If the condition is wrong, the second one is used. So k is equals to I. K is equals to I. K is holding the row, I is also holding the row. So if the rows are same, L will be J, otherwise it will be 0. If the rows are the same, L will be J, otherwise it will be 0. So it started right here. This was right here. So if k is equals to I, if the rows were same, but now but when this swap is done, the rows will increase. Because the inner loop terminated and the rows k increased to +1, so it came to 2. So L has to move to the 0th position because this condition is forfeited. So it moves to the 0th position and then performs check again. 11, 12, 0, 8. Good. Then it continues to move in its same position. Good. After that, the outer loops move to the next position. This starts at the same position because we are starting at the same position so that it does not go out of bound. Then it moves to the next. K, both the rows are same, so it remains at the same. When both rows are not the same, the inner loop starts at 0th position. The 0th position it starts, it needs swapping, it does the swap, and then the inner loop moves to the next position. It requires swap again, so it does the swap and it moves to the next position. It doesn't require the swap, and then the outer loop moves to the next position. The inner loop starts at the same place. Then it moves to the next position, it checks and it requires swap, so it does the swap. So that's how it works. To do the swap, for descending order it will be less, and for the ascending order it will be more, because we do things in reverse. Because only if it is wrong, then the swap is needed. If it's already right, we don't do the swap. So this is also a bubble shot because we are swapping every time we find a new number and not at once like in selection sort. But it is not exactly bubble shot, but you can call it a bubble shot. So this was the program for full shot Java. Let's run the program once to see the output. So this is the size. Let's enter the size of the array 3, then numbers in the array 2, 1, 6, 4, 8, 9, 7, 23. Okay, so it's sorted in the descending order 23, 9, 8, 7, 6, 4, 4, 2, 1. Okay, so perfect. Thank you.